Hello friends, welcome back to my class, that is Concept by Pandey sir. We are having a series of classes on engineering graphics. In the previous class, all the before classes we have done the basic of engineering graphics, types of pencils, arrows, polygon, conics, and also we have dealt the basics of projection of points, that is how to name a point P, how to name a point P, how to name a point Q, how to name a point R, and how to name a point S. Like P is above HP, in front of VP. Okay, so please, if at all you did not followed my class, so please go back to my previous class and just understand the concept, because that would act as a foundation or base for your upcoming classes. Please go back to my previous classes and know the basic in projection of points. Now today we shall discuss about how to project a point. How to project a point. You all know that this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And this is a horizontal plane. This is my vertical plane. Now let us imagine. See, before that, now remember that to understand or to what we can say to project any point, we should look the point or we should look the plane in two different views. First one is from front view. We should look from front view, and second one is look from top, that is aerial view. Now for instance, let us see an example. See this eraser. Okay, see this eraser. I have kept an eraser or an object. Now to understand it, now this is my eraser, right? Front view in the sense, see, if you look from this side, that would be my front view. If you look from front view, you can see the shape of this eraser. You could see the shape of the eraser because you're looking from front, right? Now the same eraser, now since I'm taking video from top, so this should be my aerial view, this should be my top view. So this top view, if you look at the top view, you are able to see only this shape, right? That is top view. So if I look from front view, I could see the shape of eraser to be rectangle, right? That is from my front view. If I look from top, I could see the shape of this eraser only from top. This is also called as aerial view. Okay, now I'll just give you another example. Okay, just a second. Let me take a smaller pencil that would give you a more detailed example. Okay, this is the pencil. This is a pencil. Okay, this is a pencil. Now the same pencil, now this pencil is a straight line. Okay, this pencil is a, see, this pencil is a straight line. It is a straight line. Now for the same pencil, if I want to project it on 2D plane, I should look this pencil from two different directions. Okay, or two different plane. I should look from front view as well as from aerial view, that is top view. Now same pencil, imagine this is a straight line. If I look this pencil from my front view, from this side, I'll be knowing the whole length of this pencil, right? I'll know what is the length of this pencil from front view. If I look from aerial view, the top view, I'll be seeing only this tip of this pencil. See, can you see total length of this pencil? Can you see? No, you could see only something that is black. You're not able to see this length of this lead, black thing, but you could see that there is a something black at the top. Okay, so that is my top view. Now if there is a point P, if there is a point P here, if I lit a torch or if I see it from my front side, that is my front view, the image of this P has to fall on this plane, let that point be P dash. So remember that front view is always represented with a dash, P dash. Now if I look the same P from top, what would happen? The image of this P should fall somewhere here, right? Should fall somewhere here. That is in the form of 3D. But you are drawing on a sheet of paper, that is on a 2D. Now, how to get the 2D shape? In 2D shape, what you have to do? You have to rotate this horizontal plane in this direction to degree of 90 degree. To 90 degree. Let us see how. Now there is a point P dash here, so in front view image is falling here, right? Now since I am looking from top view or the aerial view, image has to fall here, but I told it to convert into projections into 2D, rotate this HP, rotate horizontal plane to a degree, to angle of 90 degree. So when you rotate, so just see the point. So this, when you're rotating this, so this comes down, this is moving up, this is coming down, this is moving up. So this point will be transferred to somewhere here. Gets transferred to somewhere here. That is top view. I'll say once more, please remember. Let us imagine there is a point P here. Okay. And there is a point P here. Now since to know its front view and top view, look this point P from front view. This image has to fall here. That is called as P dash. So that is my front view. Now for top view, if I look the same P from top, the image has to fall here. Image has to fall here. That is in the form of 3D. But you are drawing on a sheet of paper, means convert 3D to 2D. So how to convert? Now rotate this HP to a degree of 90. Rotate in the sense, rotate in this has to move down. When this moves down, the point will also move down and it will come somewhere come here. Okay, so in the first quadrant, if this is my reference line XY, this reference line is what? It's horizon. See here, 0, 0, that's horizon. So at this horizon, this is what is X, whereas Y. So this XY is what? It is also in horizontal plane, in vertical plane. So XY represents a reference line, that is HP and VP both. Okay. Now since this P dash front view is above XY, so in first quadrant, front view P dash is above XY and top view P is below XY. So remember that in first quadrant, front view is always above XY or reference line and top view is always below XY or reference line. That is in the case of first quadrant. Let us see in the second quadrant. So there is a point Q, right? So if I look this point from front view, its image has to fall here. So Q dash front view. So from front view, image is falling on VP, that is Q dash, right? That is my front view. So if I look the same Q from top or from aerial view, image has to fall somewhere here. Image has to fall somewhere here. But to write in a 2D, you should rotate this HP to a degree of 90. So when you're rotating this P, this comes down, this will obviously then go up. That's it. Now if I move this one downward, this will automatically move upward. So this point gets transferred somewhere here. So in second quadrant, if this is my xy reference plane, its front view q dash and the top view q both lies above xy plane. In second quadrant, the front view and top view both lies above xy plane. Let us come to the third quadrant. Look at this R from front view. The image of this R has to fall somewhere here, right? R dash, that is front view. Look at the point R. So if you look, R dash is front view is here. Okay, so since front view is here, now my thing is I should know its top view. I should find its top view. So this top view image has to fall here, R. But to convert into 2D, I told you have to rotate this to angle 90. So when you rotate this one toward angle 90, if you rotate this one comes down, this has to move up. Now this R will be transferred somewhere there. This R gets transferred somewhere there. So in third quadrant, this is my xy front view. R dash is always below xy and top view is above xy. Okay, come to the last quadrant, fourth quadrant. So in fourth quadrant, S. So look at this S. So the image has to fall here, somewhere here, S dash. This is my front view, S dash front view. Now look at this S from top view. Image has to fall here, but you have to rotate this to a 90 degree. You have to rotate this to a 90 degree. So when you rotate, this S will fall somewhere here. So in fourth quadrant, if this is my xy, the front view and top view both lies below xy. So please understand the concept. Doubt you can ask me. Please like, share and subscribe my channel. Thank you.